Today I'm going to teach you how to apply molarity when it comes to stoichiometry and conversions trying to predict products. In today's example, it says a 200 milliliter solution of 1 molar lead-2 nitrate is added to a 200 ml solution of 1.5 molar sodium iodide and a solid lead-2 iodide precipitate forms. Find the maximum mass of the lead-2 iodide solid product that could be produced. In this type of problem, if you're not already given the net ionic equation, then you would need to find that. So, but this is already given, so we don't have to go through those steps. But normally we would have to write out the molecular equation and then the complete ionic and then net ionic in order to get this equation. So what we're going to do is, since we're given molarities and not grams or liters of a gas to start with here, in order to find the solid product, I'm going to manipulate essentially my numbers here, my 200 mils of solution, and with it being 1 molar, in order to get to moles. So what that's going to require me to do is convert this to liters first, then use my molarity units to cancel out liters and get to moles. I'm going to have to do this as well for my sodium iodide, so I'm going to have to essentially find the limiting reactant. All right, so first thing I'm going to do is I'm going to write down, I'm going to change this 200 mils to liters by moving that decimal point 3 times over. So I've got 0.2 liters of lead-2 nitrate. And then what I'm going to do is use my molarity to find to essentially get from liters to moles. So my molarity of the solution is 1 molar. So I'm going to say I have 1 mole of lead-2 nitrate in 1 liter. So that allows us to cancel out liters. All right. Now that I'm at moles, I'm still not, I need to essentially get the lead-2 nitrate reactant to the reactant specifically that's going to contribute to our solid product. So what I'm going to say here is that in 1 mole of lead-2 nitrate, I'm going to, based on its formula, I'm going to say how many of these lead ions are there. There's only 1 lead ion because there's not an additional subscript there. So 1 mole of my Pb2 plus ion. So now that I have something that's in my chemical equation, I can now use my coefficients to go from my lead ion to my lead-2 iodide product. So this is where the stoichiometry part, this is my mole ratio. I only have 1 mole of lead-2 and 1 mole of PBI. Again, that's based on these coefficients here. So now that I've finally found that, I can now take moles of lead-2 iodide and convert it to grams. So I'm going to say 1 mole of I2. I'm going to add up that molar mass. So if I look it up super fast, my lead here is 207.2 grams. Each iodide, but there are 2 of them there. So each iodine is 126.9. So I'm going to add that all up together to get my total mass. All right, so we get a total of 461 for this compound. All right, so since I finally have mass of PBI2 or my solid product, I can now use multiply across the top, divide by everything on the bottom. So it just really looks like I'm taking 0.2 times this 461. So this is going to produce 92.2 grams of lead-2 iodide. All right, so I've got to do the same exact thing for my other starting amount. So I'm also given 200 mils here of 1.5 molar sodium iodide. So just like I did before, I'm going to take this decimal, move it back 3 times to get liters. So I'm starting with 0.2 liters of sodium iodide. Then I'm going to use my molarity that I was given, which is 1.5 molar, to cancel out liters. So there's 1.5 moles of sodium iodide in 1 liter of sodium iodide. Once I've done that, similar to what I did before, the ion in this compound, so the ion in this compound that's contributing to our solid product is iodine, and so I need to say how many iodide ions are there in one single unit here of sodium iodide. So I've got 1 mole sodium iodide is 1 mole of iodide ions. It's just 1 mole again because there's not a subscript. All right, so now that I'm finally at an ion here that appears in my net ionic equation, I can use this mole ratio to convert from these ions to my solid product. So there are 2 moles of iodide for every 1 mole of lead-2 iodide. So, let's see. 2 moles of iodide for every 1 mole of lead-2 iodide. And then once I'm done with that, I can convert to my solid product using that same molar mass above. Please disregard my dog barking. So again, I'm going to multiply across the top here. And then divide by 2. So my limiting reactant, just like before, is always going to be the one that produces the least. So this 69.15 is going to be the amount of product that I am actually going to be able to make, because this is a smaller value. And that's it. So technically, if you were asked for a limiting reactant, that limiting reactant would be your sodium iodide. And the maximum amount you could produce, again, is this 69.15. So hopefully this helps when you are trying to convert or use those molarities in a stoichiometry conversion.